Uh, Problem number 1. An ideal auto engine operating on the hot air standard with K is equals to 1.34 has a compression ratio of 5. At the beginning of the compression ratio, the volume is 6 cubic feet, the pressure is 13.75 psi, and the temperature is 100 degrees Fahrenheit. During the constant volume heating, 340 BTU are added per cycle. Find C, T3, P3 efficiency, and the mean of effective pressure. To find C, we need to use formula. C is equals to 1 over RK minus 1. So substitute lang natin yung RK, which is 5. Makukuha na natin na C is equals to 0.25 or 25%. Next natin is yung temperature 3. Kailangan natin ng temperature 2, ang mass at ang CB natin para makuha ang temperature 3 kasi gagamitin natin ang formula na Q is equals to MCB multiplied by T3 minus T2. Para makuha natin ang T2, kailangan natin ang formula na T1 over RK raised to 1 minus K. Substitute lang natin yan. T1 is 560 degree Rankine over 5 yung RK natin, compression ratio raised to 1 minus 1.34. Yung K na constant. Makukuha natin is 916 degree Rankine. Next naman, para makuha natin yung mass, gagamitin natin yung P1 B1 is equals to MRT1. Substitute lang din natin yung value niyan. Tapos shift solve lang tayo sa calculator. Ito ang makukuha natin. 0.398 pounds. Next ang CB delta T. Ay ang CB is equals to Rankine over K minus 1. Direct substitution lang din tayo. Ang makukuha natin sagot is 0. Ang makukuha natin sagot is ang 156.92. Ang dahil meron na tayo ng tatlong missing natin, yung Q, mass, tsaka yung CB, tsaka yung T2, pwede natin makuha yung T3. Substitute lang natin dito yung mass, yung CB, tsaka yung T3, yung hinahanap natin minus T2. Ang T3 natin ngayon is 5203.558 degree Rankine. Next na missing natin is yung pressure 3. Para makuha natin yung pressure 3, kailangan muna natin mahanap ang pressure 2. Which is ginamit natin ang formula na T1 over T2 is equals to P1 over P2 raised to K minus 1 over K. Direct substitution lang din tayo dito. Given na yung temperature 1 natin, temperature 2 is na-solve din natin para nung gagamitin natin sa temperature 3. Ito. Next yung K is yung constant minus 1 over K. Kaya makukuha natin ng 118.82 APSIA. Para makuha natin ang pressure 3, which yung hinahanap ng problem, gagamitin natin ang P2 over T2 is equals to P3 over T3. Diderive lang natin ang formula is P3 is equals to P2 T3 over T2. Direct substitution lang. P3 is equals to, makuha na natin ang pressure 3, 638.829 PSIA. Next is ang efficiency. Ang formula na kailangan natin dito, 1 minus 1 over RK, K minus 1. Substitution lang tayo, 1 minus 1 over RK, yung 5, 1.34 minus 1 is equals to 42.14%. Next natin ay okay ng PCC, ang mean of effective pressure. Para makuha natin ang mean of effective pressure, kailangan natin ang W net. W net is equals to efficiency times QA. Ang efficiency natin is ito, 0.42, 340 BTU. W net is equals to 143.276 BTU. Next din natin na kailangan isang VD is equals to V1 minus V2. 6 cubic feet minus 1.2 cubic feet. Which ang BD natin is 4.8 cubic feet. Ang kailangan natin formula is W net over BD. Direct substitution lang tayo. Tapos kailangan natin ng conversion para sa cancel of units. Makukuha na natin ang PM is equals to 161.268 PSIA. Next problem tayo. Halos same lang siya ng problem 1. Ito yung problem 2. An ideal auto cycle engine with 15% clearance operates on 0.227 kilograms mass of per second of air. Intake state is 100.58 kPa, 37.7 degrees Celsius. The energy released during combustion is 110 kilojoules. For hot air standard with K is equals to 1.32. Now compute. We need to compute pressure 2, volume 2, temperature 2, and W net efficiency and the PM. Para ma-solve, next is we need to solve yung compression ratio natin para magamit natin sa formula ng P2 is equals to P1 times RK raised to K. To solve for sa RK natin is equals to C plus 1 over C. 0.15 which is yung given na clearance natin sa number 2 plus 1 over 0.15 is equal to 7.667. Now, substitute lang natin yung pressure 1, yung 100.58 kPa sa tapos yung RK na 7.667 at yung constant na 1.32. Makukuha natin ang pressure 2 na 1479848 kPa. Next naman natin is kailangan natin ang volume 1 para magamit natin to sa pagkuha ng volume 2. De-derive lang natin yung formula ng volume natin mula sa P1, B1, MRT1 which is MRT1 over P1. Direct substitution na makukuha natin sagot ay 0.201 cubic meter per second. Next na formula para magamit natin para makuha natin ang volume 2 isang RK compression ratio is equals to volume 1 over volume 2. Sa-substitute lang natin sila, direct substitution. Yung RK natin nakuha kanina, 7.667 over B2. Yung B1 natin, 0.201 cubic meter. Kaya yung kakasolve lang din natin dito gamit yung P1, B1, MRT1. Input lang sa calculator, makukuha nating volume 2 is 0.036 cubic meter per second. Nakuha na natin ang pressure 2, volume 2, temperature 2. Next natin is temperature 2. Ang ginamit nating formula para sa temperature 2, isang T1 over T2 is equals to B1 over B2 raised to 1 minus K. So meron na tayo lahat nito, wala na tayong kulang. I-derive na lang natin ang formula ng T2 which is T1 over RK raised to 1 minus K. Substitute lang natin yan. makukuha nating sagot is 596.240 K. Para naman sa W net natin, W net is equals to efficiency times QA. So given yung QA natin, pero yung efficiency dapat ito muna pala. Ah, so efficiency muna. Efficiency is equals to 1 minus 1 over RK raised to K minus 1. Direct substitution tayo. Ang efficiency natin is 47.89%. Ngayon, ma-solve na natin yung W net, ang work net natin. Direct substitution lang din. Efficiency, tsaka yung QA, 0.47. W net is equals to 52.679 kilojoules per second. Last is the PM. PM is equals to W net over BD, which yung BD natin is B1. Ginamit natin ang formula ang mukha nun dito. Hindi na lang natin sinow dun sa pangalawa. B1 minus B2. Ito. Sana. Ito. W net over B1 over B2, which yung BD. PM is equals to 301.023. Okay na yung number 2 natin. Next, number 3. Number 3. An air standard auto cycle operates at 100 Fahrenheit, 14 psia, and RK of 7. The maximum temperature of the cycle is 3,000 degree Fahrenheit. Determine the heat supplied per pound of air. The work done per pound of air, the cycle thermal efficiency, the maximum pressure of the cycle, and the temperature at the end of isentropic expansion. So first is to find, gagawin natin yung QA. MCB T3 minus T2. Kailangan, to solve for CB, R is equals to K minus 1. Substitute natin yan, tapos ko-convert natin to in BTU. 1 BTU is 778 feet pound. Constant natin at minus 1. CB would be 0.7171 BTU pound mass degree Rankine. To solve for QA, gagamitin natin yung CB natin at yung mass na 1. So, CB T3 minus T2. Makukuha, after mong calculator, makukuha natin is 383.14 BTU per pound mass. Next is W net natin, which is equals to efficiency times QA. With direct substitution lang din natin to with the efficiency of 0.5408 at yung QA na nasolve natin, W net would be 207.183 BTU per pound mass. Next is to solve for pressure 3. To solve for pressure 3, kailangan natin kunin muna yung pressure 2 at temperature 2 para magamit natin yung formula na P2 over T2 is equals to P3 over T3. P2 is now, para makuha natin yung P2, kailangan natin ang formula na P1 times RK raised to K. Direct substitution lang tayo, 14 psi, RK na 7 at K na 1.4. P2 is 213.435 PSIA. Yung temperature 2, gagamitin natin yung formula na T1 over RK raised to 1 minus K. T1 is 560 degree Rankine. RK 7, 1 minus K, yung 1.4. Temperature 2 natin is 1,219.628 degree Kelvin. Ngayon, kompleto na yung isa na lang yung missing natin sa formula, yung P3, kaya pwede na natin gamitin ito. Direct substitution lang tayo. Tapos shift solve. P3 is now equals to 605.500 PSIA. To solve for T4 naman, kailangan natin ng formula na T3 over 1 over RK raised to 1 minus K. Substitute natin to. T3 is 3460 degree Rankine over 1 over RK, the compression ratio, 1 over 7, 1 minus 1.4 yung constant natin. T4 would be 1588.682 degree Rankine. Ito yung efficiency natin kanina. 1 minus 1 over RK, K minus 1. Direct substitution lang yan to efficiency natin. Next is number 4. Number 4, an Otto cycle engine with a 7:1 compression ratio has a 320 BTU per pound of heat supply. At the beginning of the compression process, the pressure and temperature are at 14.7 PSIA and 60 degree Fahrenheit. Assuming constant specific heat, calculate peak temperature, peak pressure, net torque, at thermal efficiency. To calculate natin ang T3, kailangan natin ang T2. Mauuna tayo sa T2. T2 is equals to T1 over RK raised to 1 minus K. Direct substitution. Makukuha natin ang T2 natin 1132.511 degree Rankine. Dahil meron na tayong T2, pwede na natin gamitin ang Q is equals to MCB multiplied to T3 minus T2. Substitute natin ang 320 BTU per pound. Gagawin natin itong feet pound. Kaya multiply natin siya na 778 over 1 BTU. Is equals to yung mass natin is 133.375 T3 at yung T2 nakuha natin. Shift solve. T3 now is 299.128 degree Rankine. Next natin is ang P3. To solve for P3, kailangan nating isolve ang P2 para magamit natin ang formula na PT times T3 over T2. P2, para makuha natin yung P2, ang formula ng gagawin natin is P1 times RK raised to K. So, direct substitution lang din to. P1, 14.7. Yung RK natin 7. Yung K natin 1.4. P2 is 224.10 PSI. 107 PSI. So, pwede na rin tayo mag-direct substitution dito. P2, T3, at T2. Ang pressure 3 natin is 593.483 PSI. Next, para ma-solve natin ang W net, Solve muna natin yung efficiency. Yung gagamitin natin yung formula na 1 minus 1 over RK raised to K minus 1. Yung RK natin na 7. Yung constant natin na 1.4. Efficiency natin is 54.10%. To solve for W net, gagamitin natin yung formula na efficiency times QA, which is 0.541 at 320 BTU per pound. W net natin is 173.12 BTU per pound. Next na problems number 5. An ideal Otto cycle using air has the following conditions. At point P1, at point 1, P1 is equals to 14.5 PSIA and 80 degrees Fahrenheit. The heat added to the air is 370 BTU per pound per cycle. If the maximum temperature is 3,400 degree Fahrenheit and K is 1.4, compute the pressure, temperature, volume at each corner of the cycle. The compression ratio, mean effective pressure, and the cycle thermal efficiency if CB is equals to 0.172 BTU. Solve for temperature 2, gagamitin natin yung formula na is QA is equals to MCB times 3 T3 minus 2. So given yung QA natin, 370 BTU, pati yung CB, at yung mass natin na 1. Hindi na natin nilagay. Tapos yung T3 natin na given din, 3,400. Shift solve tayo, makukuha natin ang temperature 2 is 1248.837 degree Fahrenheit. Pressure 2, kailangan gagamitin natin yung formula na T1 over T2, P1 over P2, K raised to K minus 1 over K. T1 is given. T2 is kakasolve lang natin ito, 1248.837. P1 given din, 14.5. Yung constant natin na 1.4 minus 1 over 1.4. So shift solve, makukuha natin yung P2 na 272.747 PSIA. Next sa P3, gagamitin natin ang formula na P2 over T2 is equals to P3 over T3. So yung pressure 2 at temperature 2 is na-solve natin. Tapos yung temperature 3 given natin. Kaya pwede na natin i-shift solve, makukuha natin yung P3. Which is 742.563 PSIA. Okay na yung pressure. Pressure 2, 3, pressure 2. Sa volume 1 natin. Volume 1. Gagamitin natin dito is yung P1, B1 is equals to MRT1. So direct substitution lang din to. Pero pwede rin derive tulad ng itong ginawa ko. B1 over mass equals to RT1 over P1. So ito yan, 53.35 times 54, 540 degree Fahrenheit over 14.5 PSIA, tapos conversion natin ng feet to inch, 144 inch over 1 feet. Makukuha natin ng B1 na 13.797 cubic feet per pound mass. At ang makukuha na rin natin dito, ang B4 natin, dahil B1 is equals to B4. Next natin is ang volume 2. gagamitin natin formula is T1 over T2 is equals to B1 over B2 raised to 1 minus K. Yan, substitute lang natin yan. T1, T2, yung B1, which is yung kakasolve lang natin dito sa taas. At ang constant na K, yung B2 na missing. Sip solve lang ginawa natin dito. Makukuha natin is 1.696 cubic feet per pound mass. So meron na tayong B2. Next is ang RK. Gagamitin natin ang formula, compression ratio, na B1 over B2. So yung B1 is 13.797 at B2 na 1.696. Compression ratio natin is 8.135. Next natin to solve is ang B3. B3 times B3 is equals to MR T3. Derive natin yan ng konti. B3 over M RT equals to R times T3 over P3. Direct substitution lang tayo. Yung mass natin na 1, kaya mawawala yon. Makukuha natin ang volume 3 na 1.696 cubic feet per pound mass. Next, ang solve natin is ang T4. Itong formula na ginamit natin. T3 is equals to T over T4 is equals to 1 over RK raised to 1 minus K. Substitute natin ng T3 which is 3,400 degree Rankine over T4. Yung RK natin na 8.135. Compression ratio at ang constant natin na 1.4. Shift solve natin yung makukuha natin ng 1,420.6063 degree Rankine ng temperature for para naman ang next naman natin is ang P4. Kailangan natin na formula na T3 over T4 is equals to P3 over P4 raised to K minus 1 over K. Direct substitution lang ulit tayo. Temperature 3, temperature 4, pressure 3, yung constant na 1.4. Makukuha natin ang pressure 4 na 34.461 PSI. Next is ang efficiency. Formula ng efficiency natin, 1 minus 1 over RK K minus 1. Substitute natin, nakuha natin compression ratio na 8.135 at formula ang constant natin na 1.4. Efficiency natin is 56.76%. Next na pwede natin solve ang W net. So W net is equals to E times QA. Yung efficiency natin na 0.5076 at ang QA natin na 320 BTU per pound mass. W net natin is 210.012. Pwede na natin ang kunin ng PM. PM is equals to W net over PD. 210.012 over 12.01. PM natin 17.355 BTU per cubic feet. Number 6, an ideal Otto cycle as the pressure of the beginning of the compression process is 15 psia. The temperature is 70 degree Fahrenheit and the volume is 13.08 cubic feet. And the volume and the maximum temperature of the cycle is 2,804 degree Fahrenheit and the heat supplied is 372 BTU. Using the constant specific heat 1.4, calculate the temperature at the beginning of the combustion. Para ma-solve natin yung T2, kailangan natin ng T3, MCB, at yung Q. Yung Q natin, given yan, kailangan na lang natin i-convert. Kaya 778 over 1. Multiply natin sa 372 BTU. Next natin is yung mass. Kailangan natin itong solve. Pati yung CB. Yung T3 natin given. Solve for CB. CB is equals to R over K minus 1. Substitute natin yung 53.35 over 1.4 minus 1. Masasolve natin. CB is equals to 133.375. For mass, gagamitin natin yung P1, B1 is equals to MRT1. Derive natin ang formula ng mass is equals to P1, B1 over R minus T1. Substitute natin ang P1, 15 PSIA. Volume 1, 13.08 cubic feet. Yung R. At yung T1 natin na 500 degree, 30 degree Fahrenheit. Which is kailangan pa natin i-convert feet to inches. Mass na makukuha natin is 0.999 pounds. Ito. Kompleto na at makukuha na natin yung temperature 2. Shift solve na lang to. Makukuha natin temperature 2 is 1091.886 degree Fahrenheit. Number 7. In an ideal Otto cycle, the temperature at the end of the heat addition process is 2,600 degree Fahrenheit. And the temperature at the end of the expansion process is 883 degree Fahrenheit. What is the compression ratio? So, sa number 7, kailangan natin hanapin ng compression ratio. Formula na gagamitin natin is T3 over T4 equals to B3 over B4 raised to 1 minus K. So, ang temperature T natin is 3,000. Ginawa lang natin yung Fahrenheit, ginawa natin Rankine. 3,060 degree Rankine at 1,340 degree Rankine. Is equals to, pinalitan natin ng 1 over RK raised to 1 minus 1.4. Yung constant na K. Masasolve na natin yung K dito. Yung RK, yung compression ratio, is equals to 7.836.